all regarding the properties of charges. So, there are many properties associated with the charges, children. So, let us look into that one after the other, which plays a major role. Properties of charges. First one, charge is transferable. Second property associated with charge is associated with mass. Charge is always associated with mass. And next, charge is conserved. Invariance of charge. Charge produces electric and magnetic effect. This is what I have introduced in the beginning. Electric field and magnetic field. So, charge always resides on the surface of the conductor. And one more property related to charge is charge leaks from sharp points. So, these are the important properties associated with charge, children. So, let us discuss in detail one after the other. First property is related. Charge is transferable. As we have discussed earlier, when one body is rubbed with another body, what happens? There is a tendency that the electrons move from one body to the another body. So, whenever an electrons transfer from one body to another body, these electrons are nothing but negatively charged particles. Okay. And the body which loses electrons becomes positively charged, whereas the body which gains electrons will become negatively charged. So, clearly, whenever two bodies are rubbed against each other, then one body loses electrons whereas the other body gains electrons. In this way, charge transfers from one body to the another body. Hence, we can say that charge is transferable. Okay. So, now moving to the next one is all about your charge is always associated with mass. This also we have discussed in detail. So, whenever a body loses its electrons, every electron has a mass of about 9.1 into 10 power minus 31 kg. If one electron was removed from a body, then a mass of 9.1 into 10 power minus 31 kg is been reduced. Similarly, if n number of electrons are removed from a particular body, then there is a tendency that it loses a mass of n times of 9.1 into 10 power minus 31 kg. So, whenever an electron transfer takes place from one body to the another body, the body which loses electrons, the mass of that body decreases, whereas the body which gains electrons randomly, its mass also increases. So, now the next one, third one, it's all about charge is conserved. The meaning of conserved is, as we have already studied in the concept of energy. So, this implies that charge can neither be created nor destroyed, but charge always transfers from one body to another body. So, this is all about your law of conservation of charge. So, I repeat, charge can neither be created nor destroyed. That is, it always transfers from one body to the another body. For instance, to make you clear, whenever, if you consider a uranium, okay, so during the process of decay of uranium, you observe that uranium 92-235, after decaying, it becomes thorium 92-231. Okay, as a result, uranium 92-238, when after decay process, a thorium 92-234 is released along with an alpha particle. So, what is an alpha particle? Alpha particle is nothing but helium particle whose atomic number is 2 and mass number is 4. That means, so alpha particle indicates that helium-24. During the decay process of the radioactive element like uranium 92-238, after the decay process, it converts into thorium 92-234 by releasing an alpha particle. Alpha particle is nothing but your helium-24. So, as we have said that the charge is conserved. Charge is neither created nor destroyed. So, what is the atom here? Atomic number here is 92. So, it consists of 92 number of electrons and whereas 92 number of protons. After converting into thorium, okay, yeah, after converting into thorium, okay, this thorium, atomic number of thorium was 90. That means the thorium consists of 90 number of electrons as well as 90 number of protons, as its atomic number is 90. And helium has 2 electrons as well as 2 protons. Altogether, 90 plus 2 is 92. Okay. After decay process and before decay, it also consists of same values, that is 92 number of electrons and protons. Even the mass also remains constant. Okay, so this indicates the total number of nucleons as well as the number of protons. So, as a result, we observed that, so whenever during the decay process, the atomic number remains, the total atomic number remains same. That means the number of electrons and protons remains same. Only thing is that they will be transferred from one particle to the other particle. Hence, we can conclude that charge always remains constant. It is converted from one form to the another form. That's it. Well, moving to the invariance of charge. What is meant by invariance of charge, children? So, whenever we see that atom, if you consider inside the atom, protons are also there inside the atom, electrons are revolving around the nucleus, whereas protons are present inside the nucleus. So, something like this, this is nucleus and here electrons will be revolving around the nucleus. So, if you observe that the protons present inside the neutrons will also move, whereas the electrons present outside the nucleus also moves. But if you observe carefully, the velocity of the electrons is very much large when compared to the speed of the protons inside the nucleus. Okay, that means electrons will move faster, whereas the protons will move slower. So, even though they are moving, the velocity, there is a variation in the velocity, but there is no difference is being observed. Okay, that indicates your invariance of charge. So, because of the changes in the velocities of electrons or protons, the charge is not changed. The charge remains, the charge of an atom always remains same. Okay, well, charge produces electric and electric field as well as magnetic field. This is also we have introduced earlier, children. So, always remember that the rest charges at rest always produces electric field in and around. Whereas, the moving charges. So, moving is again of two types. These charges may move with constant velocity or they may move with accelerated motion. Whenever charges move with constant velocity, whose acceleration is 0, not accelerated. Okay. Whenever charges move with uniform velocity, they produce, along with the electric field, magnetic field is also been produced. But whereas accelerated charges produces magnetic effects. Okay, children. So, let me describe it once again. Yes. So, charges at rest always produces electric field. Charges in motion again categorized into two types. Whenever the charges in motion, charges are moving, they produces both electric field as well as magnetic field. Charges which are moving with constant velocity produces electric field as well as magnetic field, but energy is not radiated. This point is important. Energy is not radiated whenever the charges are moving with constant velocity. But whenever these charges, if they are accelerating, if their velocity increases gradually, then along with electric field and magnetic field, it also radiates some energy. Constant velocity, no energy is radiated. Whereas, when the charges are accelerated, when they are in accelerated motion along with electric field and magnetic field, they also radiates energy in the form of electromagnetic waves. What are they, children? In the form of electromagnetic waves. So, three categories we have observed here. One is electric field only when at rest. Other is both electric and magnetic field when they are in motion. Again, in motion, constant velocity means they are not radiating any type of energy. But when they are accelerating, along with electric and magnetic field, they also radiates energy in the form of electromagnetic waves. So, now moving to the next point, that is sixth one, charge always resides on the surface of the conductor. This is also an important point, children. So, suppose if you release a charge, then charge means same charges, whether it is a positive charge or negative charge. Let us consider some positive charge is being released. So, when you simply release a positive charge, because of positivity, all are like charges, and we know that the main property of charges is like charges repel each other and unlike charges attract each other. When a charge is released, suppose for instance, let us consider a positive charge is released. Due to repulsion, all the charges move away from each other. How long they will move? Unless a surface, until the cross-sectional area of the surface. That means, suppose if you consider a hollow sphere or a solid sphere, if a charge is released from inside at the center of either of the hollow sphere or the if you consider small charge is released, some amount of charges are released inside a sphere, because all are positive charges, as I have considered example, all the charges will, due to repulsion, will move away from each other and occupies the surface. Because apart from that, they can't leave the surface. So, they will be residing on the outer surface area of the given body. If this happens to be a charge hollow sphere. Similarly, if you consider one more sphere, and let this be a solid sphere. Even inside the solid sphere, if you release few charges, okay, so because as we know that from the property of charges, like charges repel each other. So these charges, when they are released at the center due to repulsion, they move away from each other and occupies the surface area and resides over the surface, because there is no scope to leave that charged body. So even if it happens to be a hollow sphere or a solid sphere, charge always moves away from each other and takes the surface area, resides only on the outer surface of that. So there is no charge inside the charged body. So no charge is present. So charge inside that, either the hollow sphere or solid sphere, no charge is present. It only covers that surface. So charge always resides on the surface of the conductor. Okay. So now next point is all about charge leaks from sharp points. Always remember children, large amount of charge is always present on the sharper edges as compared to the broader edges. Charge always resides on the sharper edges but not at the, and as compared to the broader edges. Okay. The reason for this is that this charge is, the surface density of the charge is always inversely proportional to the radius of the conductor. Surface density meaning that dense, how dense the particles are, how many charged particles are present at a fixed area. So surface charge density is always inversely proportional to the radius of the surface. Okay, that means lesser the radius, sharp body as well as the broader body. If the radius of this body, if you consider, I'll drop it something like this. Yeah. If the radius of the body is less, then more number of charge density will be there. So lesser the radius, larger charge density is there. Larger the radius, charge density will be less. So clearly, because of this concept, as charge density is inversely proportional to the radius of the surface, most of the charge is present on the sharp edges when compared to the broader edges. Next, the last point is all about the quantitization of charge. Meaning of quantitization means charge can be counted. Okay, so the total number of electrons itself indicates, the total number of electrons or the total number of protons itself indicates the charge on a given conductor. Okay, so charges can be quantized. How quantized means the number of electrons that are present on a body. Okay. Always remember that the charge of an electron is equals to 1.6 into 10 power minus 19 coulombs. The charge of an electron is equals to 1.6 into 10 power minus 19 coulombs. If the number of electrons increased, means number of electrons can be given as Ne. E indicates the charge of the electron, where N is the number of electrons present inside. So generally, if you consider a conductor, you can't have half electron or 3/4 electron. So such type of half electron or 3/4 electrons are not possible. Okay, either 1 electron, 2 electron, 3 electron, deficiency of some integer number of electrons or additional value of this number of electrons will be present, but no fractional electrons can be present. No fractional electrons transfer can take place from one place to the another place. Hence, if it happens to be a negatively charged particle, then this is taken as minus E, and if it happens to be a positively charged particle, then we can say that Q is equals to plus Ne. Together, the quantitization of charge is the number of electrons, the efficiency of electrons or the additional number of electrons present on a body, and it can be given as Q is equals to plus or minus Ne, where N indicates the number of electrons and E indicates the charge of electron. Okay. But recent days they have discovered that quarks and all, but there is no proper conditions where quarks are indicated 2 by 3 and 3 by 4, but this is not clearly mentioned in this later concept. So, clearly no doubt that charge is quantified. It is an integral multiple of a charge of an electron where N takes the values of 1, 2, 3, so on. Okay, so it can never be 2 by 3 electrons or 3 by 4 electrons, 1 by 3 electrons. So, such possibility is not there. Okay, children. So, till now we have discussed that charge, regarding the value of charge of electron is given by 1.6 into 10 power minus 19 coulomb, as well as mass of the electron is also taken 9.1 into 10 power minus 31 kgs. Okay, so let us compare in detail regarding the electron as well as charge of an electron as well as the mass of the electron, how it varies with respect to each other. Okay, well, moving ahead. So, as we have discussed in gravitation chapter regarding the mass associated with the particles, as well as in this topic we have discussed with the charge associated with the particles. Let us now compare the charge as well as mass associated with the particle. So, let us differentiate the two. So, first one, charge, and next is all about your mass. First one, regarding the charge, electric charge, how many types of charges are there? There are 3 types of charges. One is positive charge, the other is negative charge, whereas one more is no charge. So, zero charge, no charge. So, in general, there exist 3 types of charges: positive charge, negative charge or neutral charge. What is positive charge? Less number of electrons positive. If a body loses electrons, then it has a deficiency of electrons and hence it is positively charged. If a body gains some number of electrons, its charge is negative. Okay, then it is negatively charged particle. If a body have equal number of positive and if a body have equal number of electrons and protons, then the charge is neutral. That means zero charge. Whereas if you compare the mass of a body, no positive, no negative, no zero. So, only mass is that we have only positive mass is there. No negative or no zero mass. A body existing means some positive amount, some value is there. There is no electron-like system over here. So, what we considered is types of charges. We have 3 types of charges exist in general, that is positive charge, negative charge as well as neutral charges. Whereas mass is only one format is there, that is positive mass is only considered into consideration. Next is all about charge is quantized. Just now we have discussed that charge can be measured. Charge is quantized. Whereas coming to the mass, the quantity of mass is not yet established. Regarding the quantity of mass is not yet established. Okay. Well, next is electric charge is always conserved. Electric charge is always conserved. Okay. Whereas coming to the mass is not conserved. Because charge can be converted from one form to the another form, but mass cannot be converted, because if you consider a mass, as we say that light concept and all, you know that. So, mass, the rest mass and all concept, okay, corpuscular theory and everything, you will be learning that mass can be converted in the form of energy. Okay, this we will be learning in the higher studies. Mass can be converted in the form of energy. Whereas this electrons or protons cannot be converted in form of energy. So, we can say that clearly, charge is always conserved, but mass is always not always conserved. Okay. So, it has its own formula. The mass of a body can be written as a root over rest mass of the body upon 1 minus c square. So, formula is there. In higher classes, you will be learning it. I won't want to confuse it. So, one more condition regarding this charge is that force between two charges, if you consider, we know that like charges always repel each other, whereas unlike charges attract each other. So, they have two types of forces. One is attractive force and the other is repulsive force. Both exists. But whereas coming to the mass, only one, because this we have learnt in already Newton's law of gravitation. So, every mass attracts in a universe, attracts every other body. So, only one property exists in nature, in the universe, that is attractive property. Hence, there is no concept of repulsion, only attractive property is there. So, this is the main points you need to understand regarding the difference between the charges and mass. Okay, children, I hope you understood the concept well. Well, in next class, let us move to the next topics. Okay, until then, keep practicing. Thank you.